I wanted to record on this computer rather than the cloud. Never mind. Okay, this Zoom session is being brought to you by the Fractal Cybernetic. All right, for today. Section 1.3, talking about graphs of functions. Well, first, you define a function as a rule, generally called f, which takes an input x and yields an output f of x. A calculator is basically a box full of functions. The domain of f is a set of all possible inputs. The range of f is a set of all possible outputs. You find the value by substitution and evaluation. For example, if f of x equals 3x squared plus 2x minus 4, then what's f of 0, what's f of 1, what's f of negative 1? Well, in each case, you substitute in here. 0 here and here for x, 1 here and here for x, negative 1 here and here for x. And after a bit of arithmetic, f of 0 is negative 4, f of 1 is 1, f of negative 1 is negative 3. Okay. The graph of a function is a set of points in the Cartesian point with coordinates x by f of x. So we say, this is for the equation y equals f of x. So set of points x by y, where y equals f of x. It's a point on the graph is over x and up f of x here. Since a function yields a unique value of f of x for any given input x, that means that any vertical line will have to meet the graph of a function at most once. It's called the vertical line test. So for example, this is the graph of a function because every vertical line meets it only once. This is not a graph of a function because here's a vertical line that meets it 1, 2, 3 times. If you take the graph of a function and project that graph onto the x-axis, these x values are the domain of f. If you project the graph onto the y-axis, these values are the range of f. J5. Who's J5 again? I keep forgetting. J5. Who's J5? Alvarado. Okay, fine.
Present. Sorry for being late.
Okay. And all right. So that's how you, now we define the domain of a function is where the function is defined. So we don't allow division by 0, and there'll be no square roots of negatives until later on when we talk about complex numbers. So really, the domain of a function is relative to what kind of numbers you're willing to accept. So for example, 1 over x squared minus 9, what's its domain? Well, we have to have x squared minus 9 not equal to 0. And that means x will not be plus or minus 3. So it's every number except these two. Here's a function square root of x minus 5. It's defined where x minus 5 is at least 0. So it's where x is at least 5. So here's the graph of its domain. And here's a fun thing you'll be seeing later on when we get to calculus, something called the difference quotient, also known as Newton's ratio. It's the slope of a line through 2 points on the function's graph. Here's a point x by f of x, and you move over h to here x plus h. So here's f of x plus h by f of x plus h. The slope of this line is the difference quotient, Newton's ratio. So it'll be the difference of f's f of x minus h minus f of x divided by the difference of the x's, x minus h plus h minus x. And so it's f of x plus h minus f of x, all divided by h. This is also known as delta f over delta x, where delta means means difference. So it's the change of f, the difference of the f's, divided by the change in x, the difference in the change of x. Later, when you get to calculus, what you'll do is you'll let let h approach 0 until you get the slope of a tangent line, but that's for later. So, for example, is a cube root of x a function? Yes. Given an x, you plug it in, cube root is defined. Now here, is 2x squared plus 3x equal 1 a function? No. You can set x equal to 0, then y can equal 1 over root 3 and negative 1 over root 3. So both 0 by 1 over root 3 and 0 by negative 1 over root 3 are both on the graph. Two y values for the same x value, therefore not a function. Here's f of x equals 3x squared plus 2x plus 4. What's f of negative x? What's negative f of x? Note the subtle difference. Here we take negative, then f. Here we take f, then negative. What's the f of x plus 1? What's f of 2x? What's f of x plus h? Well, f of negative x, we plug in negative for where all these x are. 3 times the square of negative x plus twice negative x plus 4. Okay, negative square of negative x will just get you x squared. And this is negative 2x. So 3x squared minus 2x plus 4. Here's negative f of x. We'll just take this f of x and then take its opposite. And thus get negative 3x squared minus 2x minus 4. Note the difference in these two terms. Okay. F of x plus 1, you just plug in x plus 1 wherever the x was. 3 times the square of x plus 1 plus twice x plus 1 plus 4. Okay, now I could expand this and then work it out, but that's sort of aside the point for right now. F of 2x, also it's just a lot more work than I feel need. Here, f of 2x, so plug in 2x wherever the x's are. So 3 times the square of 2x plus twice 2x plus 4. This one, okay, I'll square it out. It's 12x squared plus 4x plus 4. Vincent. Who's Vincent? Vincent. All right. And f of x plus h, 3 times x plus h squared plus twice x plus h plus 4. This too, I'm a little too lazy to work out right now. Find the domain of x over x squared minus 16. Okay, all we need, there's no square root, so the only worry is do we have a division? So we don't want any division by 0, so x squared minus 16 is not 0, and that rules out plus or minus 4. X is every value except plus 4 or minus 4. So it's this doubly punctured line is the domain. Now here, find the difference quotient for f of x equals 4x plus 3. Okay, the difference quotient is delta f over delta x, the change of f divided by the change of x. Okay, so f of x plus h minus f of x. So plug in x plus h here, 4x plus h plus 3 minus f of x, that's 4x plus 3, all that over h. All right, we expand this, distribute that. 4x plus 4h plus 3 minus 4x minus 3 all over h. Plus and minus 3 cancels. 4x minus 4x cancels. We're left with 4h over h, and that's 4. Here they ask for the difference quotient of the function 2x over x plus 3. Same deal, but more work. Delta f over delta x equals 1 over h times the change in f, f of x plus h minus f of x. I'm putting the 1 over h out to the left here, so we don't have this bulky all divide by h thing the whole way. Same thing. So 1 over h times, plugging in x plus h here, twice x plus h over x plus h plus 3, all that minus f of x, 2x over x plus 3. Okay, so now we have a difference between two fractions. We use what I call the rabbit rule. A times d minus b times c. 2x plus h times x plus 3 minus 2x over x times x plus h plus 3 over the product s plus h plus 3 over x plus times x plus 3. Okay, we expand this and this. There are a bunch of terms. 2x squared minus 2x squared cancels. 6x minus 6x cancels. 2xh minus 2xh cancels. All that's left is 6h in the numerator. 1 over h times 6h over x plus h plus 3 times x plus 3. The h's cancel, and the difference quotient is 6 over x plus h plus 3 times x plus 3. Now, here we have a graph. It's, well, spoiler alert, it looks sort of like the graph of the cosine between minus pi and pi. All right, is it a function graph? Yes, every vertical line meets it at most once. What's its domain? Well, the x values are from plus to minus pi, and the y values from minus 1 to plus 1. So domain minus pi to pi, range minus 1 to 1. What are the x-intercepts? What are the y-intercepts? And it intercepts the x-axis here and here at minus pi halves and pi halves. It intercepts the y-axis here at 1. What is its symmetry? Well, In truth, this is just the sketch, so I wouldn't, so you wouldn't necessarily know with exact precision how it's symmetrical, but it looks fairly obvious that if you flip it left for right, it's the same graph. So it's symmetrical around the y-axis. Okay, I think we're done for now. Stop share. All right, questions, comments, requests. All right, if no questions or comments or requests, then motion to adjourn. Is it seconded?
Thank you, Professor.
All right, good to you. And have a good weekend.
Thanks,
Thank you.
Professor.